So, when one substance turns into another, we know that that's a chemical reaction. And we've seen several types of equations, and we've used numbers from those equations to do stoichiometry. But we should be able to tell, based upon what we start with and what we end with, what type of reaction it is, or really by what we start with, what we should end with. And that happens a couple different ways. When we are in first year chemistry, we focused on these 5 types. When we have 2 elements or 2 compounds combining into one thing breaking down into others, so into multiples. So these are obviously opposites of one another. And there's predictable patterns. And the nice thing is that you won't really have to memorize all of those patterns anymore of how things can combine. We should know how elements combine into compounds based upon their charges and how a compound breaks apart, especially focusing on which elements are diatomic. A single replacement, or sometimes single displacement reaction, we've got an element by itself, and if it's more reactive than the element in the compound, it would kick that out. So certain metals react with acids, whereas others don't. Certain metals dissolve in solutions of other metals, whereas others don't. They swap ions out. We've got a new thing by itself and then a new compound. And an important piece right here is that element by itself, maybe it's magnesium or copper or calcium, that is the neutral metal. So it's not going to have a charge. But when it's in the compound, it has the charge. So in this, we're gaining and losing electrons as we swap our ions. A double replacement is 2 ionic compounds trading partners. This can happen with 2 ionic things, with acids and bases. This is probably the most common that we would have to predict the products on in AP Chem. It's the simplest, though. You just swap partners and you pay attention to charges. But everything keeps its charge. We're not, as we swap partners, gaining or losing electrons. So that's an important piece. Sometimes we make precipitates or gases or liquids, though. And then combustions are very important, especially in terms of the way we can analyze things, but they have the simplest predictions: carbon dioxide and water when something burns in oxygen. But these 5 that we talked about are really variations based upon what we're starting and ending with instead of about the process of change. So down here, this is the way that we're going to classify a lot of things, or the way we would want to be able to talk about reactions. And some of these can apply to many up here. So precipitation really mixes most with the idea of a double replacement reactions. We swap partners and we end up with a solid. You'll see that a lot, and we'll be able to easily predict that. Acid-base reactions sometimes could be many of these up here, sometimes could be involved in a double replacement, but the main idea is that we have a hydrogen ion that's being gained by one thing because it's lost by the other. So the hydrogen ion's being transferred. The most common, because it's what's happening in synthesis, decomposition, single replacement, and in combustion, is an oxidation reduction. Anytime we are truly making and breaking bonds, most of the time something's gaining and losing electrons. And most of the time there's a transfer of electrons. So it can look very simple if it were in a net ionic form, or it could look like a synthesis. Here they are neutral, and when they combine, it's those opposite charges because one thing gained and another lost. Here they have positive and negative charges but become neutral, once again because of gain and loss. The A by itself likely loses electrons to get a positive charge so it can bond. The B gains those electrons to be by itself. As carbon goes from bonded to hydrogen to carbon dioxide, it exchanges electrons there. Sorry, I spaced out for a minute. It's got a negative charge here generally, a positive charge there. So it is losing electrons, and the hydrogen is gaining electrons in order to be able to, the hydrogen's keeping them. The oxygen, is gaining the electrons to be able to go from neutral to negatively charged. So all of these are types of reactions, way less product prediction and more understanding and classifying them. So we'll spend a little bit of time with each, really focusing on these last 3 because how they help us to understand the first 5.